Tension or suction or soil water potential. And that's also what you're talking about when you're talking about field capacity or wilting point. Now, those two are related. So when soil is really dry, the remaining water is attached strongly to the soil particles. When it's really wet, it's all kind of loose and it can go anywhere. So in this graph, you have the soil water potential on the vertical axis and the soil water content, the volume, on the horizontal axis. And you can see the extreme points, so extremely dry and extremely wet. And then in between field capacity and wilting point, you have different shapes of curves. And the shape of that curve determines how much water is available for your plants between field capacity and wilting point. So a sandy soil has only a very small volume of water available between those 2 points. A clay soil and a loamy soil have way more water available for extraction by the plants. With soil moisture sensors, you can measure either the volume of the soil, of the water in your soil, or the suction or tension or potential with which that water is attached to your soil particles. So most volumetric measurements depend in some source on the electric properties. They send out a little current in the surrounding soil. Then the amount of that's reflected to the sensor determines the reading of this instrument. So you could dig a pit into the soil and place a sensor like this at different depths, and that would give you a range of readings of soil water content at various depths within your soil. This thing, on the other hand, you just dig it in entirely, and it'll give you one number for the entire length of the probe. The instruments that measure soil water suction or soil water potential are all based on having a porous material, either a ceramic or a gypsum block inside this sensor, that gets the same soil water suction as the surrounding soil. And then you measure either by current or by measuring the drawdown of water, how strongly the water is attached to this material. So with these instruments, you would be able to tell whether your soil is close to a wilting point or closer to field capacity or anywhere in between. So the drawback is that you can measure only one thing. So unless you buy two systems and then install them both at sort of the same positions in your field, you can say, okay, it's time to irrigate because I'm so far away from wilting point or so far away from field capacity, but then you don't necessarily know how much you should irrigate because that would be derived from the other sensors. Unless you take a soil sample into the lab and let somebody determine the shape of this curve, and then you would be able to say, okay, I measured that I'm right here at 1000, so that means that if I want to go all the way back to field capacity, I have to add a certain amount of water. The advantage of using sensors is that it gives you a record, so you can keep track of what happened in your soil throughout the growing season, and it's really easy to also look at what happens at depth. Initially, you might mainly be interested in the soil moisture content of the shallow root zone, but at some point, when the roots grow deeper, it can also be really useful to know what is happening at, say, 50 or 60 centimeters depth. And yeah, if you just auger in every time and sort of feel the soil, that might be, it takes a lot of time and effort, and it also, you need to keep track in your head, like, okay, how did the soil feel like a week ago or 2 weeks ago, and is that any different? The changes might be small, so you might forget that. Usually what you do is get a couple of sensors and place them at several depths, so that you have an individual reading for the shallow and the deep root zone, and maybe also for something below to see if you're leaking water. Or otherwise, for instance, with these probes, you can only really measure one sort of depth, but you could buy a couple of them and then put them in different locations in your field where you expect differences in moisture conditions, either based on topography or on soil type. The techniques to measure have not really changed that much over the last 20 to 30 years. The principle is always kind of the same, but there has been quite a lot of progress in the ways that the data is then collected and transmitted to either a computer or your phone or a program online. So a lot of these things would now come just with an individual solar panel, and you'd have to insert maybe a SIM card or sometimes just a radio signal, and then they will, whenever you log on to your software, they'll pull out all the data from the different sensors. And if it's very fancy software, it will give you a nice map with the locations of your sensors and a color saying, okay, this is, it's green, it's good, orange, kind of dry, red, irrigate now. It's a bit, it's more work, and it requires a bit more thought than just feeling the soil, because you'll get usually not just one point, but a cloud of points, which you have to sort of interpret and figure out if it's a real signal, and then B, what does it mean, and translate it then into an irrigation decision. But it does give you a more a steady and quantifiable number and way of measuring the water condition of your soil. Yeah, so that's sort of my introduction. I hope you have questions or remarks or anything.
So when you use these sorts of devices, I mean, how often do you have problems with, the electronics, or how fragile are the systems? I mean, reliability. I mean, you talk about your Dutch auger, at least
It always
you
works.
know what you know, right?
Yeah. It depends a little bit. I have that little plot over there is my research site. I have 3 of those. They have 5 sensors, and they all come with these really flimsy wires. No problem so far. The upload of data goes wrong maybe once a week. They transfer, but they transfer 3 times a day. So if I miss one, then the next one will still give me the 8 hours of data that I missed. It's remarkably reliable. Also, the cell signal around here is pretty good. Some of the instruments that are more specifically oriented towards agriculture, like the manufacturers that make this thing, made it such that it's robust. Yeah. This has usually this would just be a metal rod, because that's the thing that would actually emit the signal, but they've coated it in a couple of layers of plastic so that, a rodent could try and make lunch out of this, but it wouldn't, it would probably give up before it actually causes any damage. So I would say in general, that's the pretty robust part of it. The not so robust part would be that you get software updates, or things are not compatible with your newer computer or your older computer. And sometimes the communication modules of those things depend on a certain GSM signal that might not always be around. So that requires some good research before you start.
So how often, I mean, you have remote sensing capabilities, so you're seeing what's going on back in the office, right? Here. So, I mean, how often do you feel like you need to get on site to kind of verify and make sure that everything's good every 10 or days or 2 weeks, or when something goes odd, or?
Yeah, it really depends. I usually just go once a week, just for my own peace of mind. But once every 2 weeks would usually be good, unless you see something strange in your data. At some point, on a different location, there was one sensor that was just continuously giving me a saturated signal. I was like, well, first I just threw out the data. I was like, well, maybe I should wait a couple of weeks before the soil is nicely settled around it. Then it kept on being wet. And I checked, and I apparently pricked a subsurface line, and it was wet, but the whole system was leaking. But yeah, the thing that you would hopefully have time for is to install it like quite early in the season, preferably even before winter, or otherwise right after you work the soil, so that the sensors really have time to get in good contact with the surrounding soil before you start making decisions based on what you see.
Important. It's really important.
Yeah.
Critical.
Yeah. So.
Do you know what the price is on a system like this?
Good question. These things would, I think you'd be able to buy a set of 5 for about $2,500.
Is that just for that, or is that for the software as well?
That's probably just for that, and then a couple, maybe, well, I'd go for $200-300 for a license for the software. These things are $2,500 a piece, just because the technology is fancier, and the measurement itself is more accurate. These sensors are $50 a piece, but you'd still need a $500 to $750 data logger to get them working. But then with the output is, you can load that into Word or Excel or whatever program you want.
And do you have to always interpret your own irrigating schedule? Is there any software that is out now that can read how much soil or how much moisture is in the soil and interpret that and basically give you a recommendation for irrigation?
There is one company that does that. They have a sensor that's similar to this one, and their algorithm is a bit magical. They upload it into the cloud, and then something happens, and they give you an actual advice. I would, especially if it's the first year that you would be using that kind of stuff, I'd check it, or just maybe do it on a smaller area. But they claim that they found a way to do that. Most manufacturers won't do that because there's always the calibration that you need to do between what the instrument measures and your soil. So most of the time people will just say, okay, we'll give you a percentage or a range, and then it's up to you to make that translation between, okay, that means that the soil just needs 10 millimeters of water, or maybe a full inch or whatever. But yeah.
Have you tried anything other than like just small plots like this? Have you tried it on any large scale pieces of land, or?
No, not yet. Not yet. We're going to do a trial with variable rate irrigation next year on a full section, and that will involve lots of monitoring as well. So hopefully.
How many of these units would you have in a full section?
It depends a little bit on the variability of the soil and the topography. That field has, I think, 1.5 meters of topography differences. So we'll put at least one on top, one in a low spot, and one somewhere halfway, depending on how variable the soil is over there. I'd sort of spread maybe 1 or 2 sections.
So if you have relatively flat land, is there any reason why you shouldn't be able to get away with just having one of these per field?
Well, even flat land, soil is just a very variable thing in general. Even if you have a full box of clean sand and you water it very evenly, if you were to measure it, you would get variation of how fast that water moves throughout your soil. So also in a normal field, I would do 2. But if you want to have it as a rough check, then I'd say 1 profile to start off with, sure. But always do multiple sensors in depth then. Yeah. Anything else? I think no.
Are these
Thanks,
basically
guys.
the 3 standard models that you would see for equipment like this, or do they have newer technology coming out that's totally different way of sensing soil moisture than these?
The method of sensing is not so much that makes it different, but they'll package it differently for sure. But yeah, unless you really go into neutron counts, the techniques that are all the same.